Before we start filling in the notes, I want you to think about these questions right here. I want you to read these three BioNews headlines and then answer the two questions that follow. You don't have to write them down right now. Just think to yourself, are these titles true? And how do you know? So go ahead and pause the video, look at each of these headlines, and think of those two questions. Okay, we're going to go ahead and get started with the notes now. We're going to look at those headlines in just a second. I just kind of wanted to give you a little glimpse at them first before we get to them later on in the notes. Okay, so starting now, a hypothesis is an educated guess. You've all heard this before in previous science classes. In your scientific method, you're looking at a problem, and the hypothesis is going to be an educated guess to the answer of that problem. You're then going to use an experiment to test or prove that hypothesis, that educated guess. There on the right-hand side, you can see the scientific method listed out in a different way that you may not have seen it before. Starting out, we ask the question, we do some research, then we form our hypothesis. After that, we're going to test it with an experiment, look at your results, and you're going to have one of two outcomes. Either you're going to find that your hypothesis was true, or you're going to have your hypothesis come up false or partially true. If it comes up false or partially true, then you're going to go back up and think again, construct a new hypothesis, and go through the process until you find a true hypothesis. And then you're going to report your results. When we're making a hypothesis, you need to remember that your hypothesis must be testable. We talked about this in the last unit, so hopefully this is a review for you. But just to kind of help you remember, you must have these three rules in effect. It must be measurable, observable, and objective. Yes, that spells moo. That's why there's a cow down there at the bottom. Measurable, observable, and objective. Okay, so let's look back at our BioNews headlines and practice the moo criteria for a hypothesis. Sewage breeds bigger, faster mosquitoes. Does this meet the moo criteria? Is it measurable? Okay, bigger, you can measure that. Faster, you can measure that. Is it observable? Can you actually see this happening? Are you able to look at mosquitoes before and after being exposed to sewage? And objective, is it fact-based or is it all based on opinion? You can actually find real measurements of each of these items, and so it is a objective hypothesis. So yes, this meets the moo criteria. Next one, dead ants communicate with the living. Is it measurable? That can be argued. I wouldn't say that it's really measurable. Is it observable? Yes, you can observe if this is happening. Is it objective? If it is happening, then it's fact-based. So this one wasn't really meeting the criteria of being measurable. It is observable, it is objective. We'd really need to look into further details. It's possible that we could strengthen this hypothesis right here and make it measurable. Okay, and the last one, scientists claim that decaying meat turns into maggots. Okay, so is it measurable? Yeah, you could count the number of maggots. So you could look at fresh meat versus decaying meat and maybe see how many maggots are in each. Is it observable? Well, of course you could look at the maggots there, but the observation part, you've got to look at what this is actually claiming. This is claiming that the decaying meat turns into maggots. So you would have to find some way to observe the meat transforming into a maggot. So as long as you could find that, then yes, it would be observable. Is it objective? I would say this is pretty fact-based. If you could show all this, then yeah, it technically meets Moo. So here's the deal. All three of these are real hypotheses that have been made at some point in time. Some of them are a little bit stronger than others. That last one is really interesting in that it is one of the things that kind of spurred off our cell theory that we're going to talk about later on in this unit. That this was a real claim that they thought that meat turned into maggots because they saw decaying meat, they saw maggots there, and they assumed, they put two and two together and said, okay, meat must turn into maggots. They didn't realize that actually the flies were coming in, landing on the meat, laying the eggs, and that's where the maggots were coming from. So just all those interesting things that you can look at, that even if it is a real hypothesis that meets that three criteria, it doesn't have to be right. That's what a hypothesis is an educated guess, and then you move on from there. Okay, so after we're talking about hypotheses, we're going to look at a theory. A theory is a logical explanation that explains physical and natural events. You have to be able to test it by multiple independent researchers. So that means like it's not just an experiment that I did, it's something that was tested by multiple people. It is well established, highly reliable explanations that have been tested time and time again. So once again, this goes back to being tested multiple times. If it's showing up test after test after test, then it is seen as reliable. And last, it can change and adapt with new technologies and discoveries as they come about. This is what's really important to science, is that nothing is ever set in stone. A new technology may come out that shows a little more detail to a theory. We may discover something else that's there that we didn't see before, and it may change that theory. It doesn't mean that that theory was wrong. We can just make it a little bit stronger as technology and discoveries come about. So that's going to conclude our notes for this section. Go ahead and find your assignment for the next step and come back to the video when you're ready to continue the notes.